Hi guys, in this video we are going to learn an interesting question from hydrostatic thrust per unit length. If you are new to this expert tutor channel, please don't forget to subscribe it. Also, we have done many videos regarding fluid mechanics as well as the fundamentals of engineering. If you like to watch them, I have given the link in the description so you can always watch them. And okay, without wasting our time, let's move to the question. So the first thing is they have given there is a dam over here and they are going to store the water, and they have given some data over here. Area of this parabolic segment, as you can see over here, this is the parabolic segment. The area can be derived by this equation. You can actually use that, and they have also given that the center of the half parabolic cross section, which means the center of this half parabolic cross section is going to be in the 4.68 meter from this zero in this horizontal direction. So it's nearly like to this part. So these are the details they have given. So in the first part they are asking about to find the vertical component of the hydrostatic thrust per unit length of this dam. So we need to find what's the hydrostatic thrust in this vertical part. First of all, we need to find the vertical component. After that, they have asked to find the total component, and we need to find the last part is we need to find where is going to act in this surface, where the resultant of hydrostatic thrust per unit length is going to act in this dam. So these are three questions. We need to figure it out those answers. If you already knew the method, please pause the video and try to figure the answer in your own, and after that compare with my answer. If you don't know, don't worry, we are going to do fully in this question. So let's move to the question. So when we are considering about the answer, there are many methods to find the hydrostatic thrust in this dam, but here we are going to use a simple method. First of all, you need to figure it out how it's going to look like. So there is a dam. Actually it can't be in the 2D, so it's like to be this side. So it's, let's draw like this. It's going to be in this direction. Let's say it's going to be in 3D like this. So after that, actually we knew that they are asking for a unit length, which means we are going to consider as this is as 1 meter for a unit length. So if we find for 1 meter, we can actually divide the total force in the dam of this 1 meter surface of the width of 1 meter, and we are going to divide it like that. We are going to get the answer. So we are going to take a 1 meter of this length. So it's going to be 1 meter, and we are going to find the answer for this 1 meter. So it means we are going to find the hydrostatic thrust for a unit length. So they are asking about that for a unit length. So we have now taken a volume of the water they have stored. So let's draw a little further so you can understand a little very clearly. So it's like this part, and it's going to be like a parabolic shape over here. So let's mark it like this. Okay, I hope you can now clearly understand how this 3D image look like. So the thing is, when you are doing a fluid mechanics, try to draw in 2D, and after that imagine that image how it's going to look like. So you can easily figure it out how to do how to tackle any hard questions if you imagine that. Okay, so if you draw that, actually we can figure it out that it's also having in the out of the paper too. If when you are considering about this part, this volume, it's going to be in the out of the paper too. In both directions, it's going to have inside the paper also. It's going to have the dams part, and out of the side also they are going to have the same part. Which means when you are considering about the force acting in this side, in this plane, in this side, the vertical side is going to be 0. So we don't need to figure it out, because when you are considering, it's going to be same for this length. When you are considering about this out of the paper and inside the paper, inside this line, and it's going to have the same force acting on both sides. So in the opposite side, the both which are going to have the same magnitude, so that it's going to cancel out. So we are going to consider in this direction, horizontal, and in vertical direction in this side. We don't need to actually consider in this side out of the paper and inside the paper. So when you are considering about that, let's draw this shape again. If you want, you can draw this shape again. We are going to consider only this water volume. So if you consider about this water volume, there are what are the forces acting on it? Actually, you can tell there would be a center of the gravitational force, because it's going to have a weight on it. So it's going to have, it's a water, so when for the equilibrium of this water there should be a force and the resultant force will be zero. So we are going to go to that concept. So when we actually knew that, when you consider about this water, it's going to have a weight on it. So first of all, we need to find the weight of this water. The next force it's going to act is, when you consider this area, it's going to have the pressure. It's like a rectangular area, so you can figure it out what's the pressure on it, what's the pressure and what's the force from this side, what's the force from this side. So actually you can figure it out. Actually we knew the length and we knew that this the with this 1 meter, so from that actually we knew the equation. From that we can directly figure it out what's the pressure on this side, and we can find what's the force acting on this. So this is the second force. What's the third force on it? If you can easily figure it out, it's going to be in this direction by this dam, so you can also figure it out. So here these are the three forces you are going to figure it out. So first of all, we need to find the weight, and this is the second force, and this is the dams, the pressure inserted by this dam and the force inserted by this dam. So here we are going to consider only three forces, and let's move to the next part. So when we are considering about this, first of all they are asking about the vertical component of this hydrostatic pressure per unit length by this dam. So we have now figured it out, there are only three forces, but the first question is, they are not asking about the total component, they are only asking about the vertical component. When you consider this image, actually we knew that this force, the force acting on this rectangular area, is going to be horizontal, which means the center of gravitational force is going to be in this direction, vertical downwards, and the dam's force would be in like this, which shows it's also having a vertical component and the less horizontal component to make this water volume in equilibrium. So we can tell that the vertical component of this the hydrostatic thrust of this dam, provided by this dam, the vertical component of that would be equal to the magnitude of this weight. For this equilibrium, we can directly tell that, because there are only three forces, and one is in the horizontal and the next one is in the vertical. So we are going to equate the vertical component to that weight. So let's say this is theta. If I tell like theta, the vertical component, which is the r cos theta, would be equals to the w, the weight of that total water volume. So we need to find the water volume weight. So how we can find that is, actually we knew that it's going to be mg, m into g, the mass of that into gravitational acceleration. So the mass would be, we can directly write it like, using the density and the volume, we can write it like this, volume into rho into g, and after that we need to know the volume of this. Actually they have already given the area of this parabolic segment. The area of this parabolic segment is 2 by 3 into width and height. So how we can find the volume of this part? If we know the cross-section area of anything, we can, as this cross-section area is not going to change over the length of 1 meter, we can directly multiply the 1 meter and we can get the volume of this volume. So I'm going to do that. So actually we knew that the area of the parabolic segment 2 by 3 into width means this one width, which is 12.5, and the height, which is, this is already, they have marked it like 50, so we can directly use it like that. So 50. So we are going to multiply by 1 to get the volume, but it's not a big deal, it's going to be the same. And the rho, the density, would be 10 to the power cube, because they are only having the water, and multiply by 9.81. So if you figure it out, the answer is going to return the vertical component of the hydrostatic thrust in that jam. So we are going to do using the calculator into 12.5 into 50 into 9.81. If I do so, I'm going to get 4087.5 into kilonewton. So now we have finished with first part.